So let me share my screen. Actually, start a browser. Let's just share that. There you go. Can you all see this?
It says Chase has started screen sharing. Oh, there it is.
Okay. It's like popping this thing all around the page. Okay.
It's just a browser window, though. I don't know what else.
That's it. Just a big play button, right? Okay.
Play button's all I can see.
Okay. All right. So I am going to be presenting what Micah titled, I think you came up with this, the 90% AI, 100% Beam. I don't remember who came up with that.
Claude did it.
Yeah, Claude did everything. Like this talk, Claude did everything. So what this is my attempt to build an Erlang VM with Zig using mostly just AI. To be fair, I did attempt this myself before AI tooling was really like all there, and kind of failed at it, and it kind of sat there on the back burner for a while. So that's the 10%. The 10% was me putting in like a couple weeks of effort in the beginning. So a little bit about me. You probably all know me. I'm Chase McCarthy. I used to work at HashRocket. I now work at Mimic with Micah and Vinny. I tried to figure out the exact numbers for this. I said 8 years of Elixir and Erlang experience in production, but I know I have more than that. But I'm only comfortable at saying 8 years in production. The first 4 years were probably, or 2 years or something, were just me fooling around. So recently, I started a real focus on really just changing the entire way I work to be AI focused and AI assisted, so I can just hit a ton of side projects all together and theoretically finish some of them this time. So today's side project is what I call Typhon, which is just a code name. Like don't take this as like the final name of anything. Just Greek Titan called Typhon that has a bunch of serpent-like heads, and so for some reason that just reminded me of Elixir and Erlang processes. So we're going to go through real quick Beam basics. I'm going to skip over this pretty fast just because I think most people here know most things about Beam. Just a little bit of background. So this is a lot of the learning that I had to do was just kind of like how the history of the Beam and the thing that came before it called the Jam, which was kind of interesting, affected where Erlang is today. And Erlang now powers some giant apps that I think all of us know about. Micah told me the other day they're like now running the NFL like camera system on Elixir, and there's a bunch of things that you just don't know about until somebody says, "Oh yeah, we're also running this billion-dollar company on Erlang or Elixir." So the thing that makes the Beam special, I think, is that it is essentially a mini operating system. It is completely driven by processes and isolation. Processes have a few different things that get spun up when you create one that make them much more lightweight than a regular OS thread, and they communicate essentially only through message passing. There's some weird things like the process dictionary and stuff where you can go around that, but that's kind of that's not the canonical way you're going to see Erlang or Elixir apps being made. So yeah, this is just the stats on how much lighter weight a Beam process is than an OS process. I didn't validate any of these numbers. These are just things that I Googled, but just we all know they're much lighter weight than OS processes, which is why all the examples of somebody showing like, we have a chat example with 7 million or something concurrent users. That's why this is possible, because if you had to actually spin up a real OS thread with that, you'd blue screen Windows pretty quick. And then this is just conceptually like because we're gonna put some more things on top of this later and then invert it. This is just how it's essentially set up. Right, you have an operating system, and then we abstract that operating system with a Beam operating system, and then you have OTP built on top of that, and then you have a bunch of things built on top of OTP itself. And then if you keep going, you have things like Elixir built on top of that even. And Elixir does reuse, for the most part, the OTP modules, but some of them it kind of replaces. And then there's the scheduler, which is also pretty critical to actually writing the VM correctly. Like it's pretty easy to take bytecode and then realize that it says do 1 + 1 and say, oh, well, that must be 2, right? Like that's actually really easy. The hard part about writing a Beam VM is the scheduler. There's a lot of really interesting like legacy decisions that were made. You don't really know why. And then there's some things that are pretty critical. One of the ones I thought was interesting was the whole, I don't know if anybody's heard the term reduction, but there's essentially a ticking counter that says every time you do something, every time you call a function, which gets a little hairy when you get inside of a NIF or a BIF, but you get like a ticker that counts off, and you only have 4,000 things you can do before you're halted, and then it passes on to another process to do something. And they call that window of time a quantum. A lot of these things actually came up many years ago, and they have weird words for things that people obviously don't use anymore. Like they didn't use the word VM, they used abstract machine. And the interesting thing about the way doing this is that if you get one process that tries to do something stupid, like in an infinite loop, it doesn't take down your whole system because it'll just spin for 4,000 cycles and then get control passed over to something else. The message passing, this diagram's a little wonky because really that mailbox actually like lives inside of the process itself. But the key here is that you have no shared state. You have a queue of messages that go into the box, and the process is responsible for pulling things out of that mailbox. There's also interesting weird things in the VM that are actually scheduled based off of message passing, like when to do garbage collection. There was a problem I had the other, a couple days ago, where I was trying to do garbage collection. I think it was at the beginning of a message being sent, and it needed to be done at the end of a message being sent or something. So a lot of things in the VM itself are based off around when control yields from one thing to another. And then there's this term that keeps coming up, and apparently has become kind of fallen out of favor in the Erlang, mostly I guess the Elixir community of let it crash, but I still like the principle of it, which is that when your processes die, they don't take down the entire system. We have supervisors, they monitor things, they bring them back up on some kind of strategy. And so yeah, it's why we can maintain very, amazing uptimes. Claude generated this number. I highly doubt that that's an actual real fact that 99.99999% uptime for anybody, but theoretically. All right, so introducing AI slop logos. So this is the logo that Gemini spit out for me. I thought it was pretty sick. So Typhon, Beam VM from scratch. So yeah, I don't know if I mentioned it earlier. This is all written in Zig. So a few reasons why Zig. One, I was learning Zig at the time. If I was on a Rust kick for a while. It might have been written in Rust if I'd written this last year, but Zig is the way it is now. But the nice thing about Zig is Zig, for the most part, still has pretty good WebAssembly support. Rust does too, but Zig is just generally easier to write. You do get more runtime problems than you do in Rust, but it's a lot easier to get to runtime. So it has a lot of C interop compatibility, and that's going to be useful for things like if you want to write NIFs, you need a language that's going to allow you to easily get a bind to C, so you can have somebody else write something like a Ziegler or Rustler NIF that you can like pull into your VM. Has comp-time metaprogramming, which is a little weird sometimes, but it's much faster than trying to do any kind of like runtime metaprogramming, or it's a lot more easy to understand because it's like checked than something like C defines and stuff like that. It has fast compile times with an asterisk. If you're using the latest like 15.0 Zig, they've moved away from using LLVM for the main compiler, and they have, I don't remember what they call their compiler, but basically they do their own compiling. But the problem is if you're targeting WASM, you have to use LLVM. And so I don't get into the fast compile times for this project because I'm mostly targeting WASM. So it also has a built-in test framework, which is a good thing and a bad thing. It's a good thing in the sense that it kind of just comes out of the box. The bad thing is so integrated into the language itself that when you need to break out and do something a little bit different, it's basically like you're rewriting large portions of the language. And then, yeah, so why target WebAssembly? It's a sandboxed environment. The nice thing, it's like, imagine Docker, right? Like, so you can run your programs and not have to worry about things like this thing went out and read a bunch of files, deleted something, whatever. You kind of isolate them in these WebAssembly processes. It's got near native performance, and you can spin them up like super fast, kill them, whatever. So it's kind of great for like scaling up quickly, which has good edge computing potential. So actually, my first kind of thought of building this was to use Cloudflare workers, which support WebAssembly, to run Elixir. So that when like the Cloudflare worker comes up, it would do something like join a small cluster and be able to get access to whatever it needed to from inside that cluster and then spin down on demand. So just imagine like it's essentially scaling up and down your Elixir cluster really fast. I don't know how that's going to work because it does actually take a few seconds to actually get joined into a cluster. So I haven't gotten that far, but that is where this came from. Yeah, and then if you could compile the WebAssembly, theoretically you can run in the browser someday. So Typhon architecture there's a couple key requirements I had. There are things that exist out there right now. I don't know if you've seen Atom VM. That's the main open source one. I can't remember what there's I think a proprietary VM that is a little better than Atom VM in the sense that it supports full OTP. But I didn't have access to that because it's proprietary. But Atom VM requires you to compile using their own toolchain, and you end up with I think they're called it's like an ABeam file or something. There's some other type of file extension that's not quite a beam. And one of my hard requirements was I need to be able to take just normal beam files that nobody knew they were compiling for this and just run them. So it has to take regular beam files. So which means that I have this bytecode loader decoder that basically just iterates through all the bytecode, and as it reads in the opcodes and the arguments, it parses out and does something based off what the bytecode said. In a little bit we'll get into what that bytecode looks like or what the opcodes look like. Yeah, and then theoretically all of this is running on a WASM native runtime that's like 800 kilobytes. So also big requirement is that it runs Elixir, which shouldn't be a problem. For the most part, Elixir is just running on Erlang. So theoretically, anything like, what is it, Gleam or anything like that that's running on Beam should easily just run on this because I'm not requiring any special compilation step that gets you down to my special VM. So what's working as of today? I've got about 127 of 185 opcodes supported, which gives most of what you actually need. Most pattern matching, anything, I've got basically more and more tests and examples and things like that. They're essentially stress testing any kind of crazy pattern matching examples that might come up. Binaries turn out to be the #1 source of my bugs that I run into. So it's weird. You would think it would be something like some complicated math or some weird, spawning a process thing on an OS, but now it's really just dealing with crazy pattern matching and binaries and stuff. And yeah, concurrency is working. I got OTP support built in, so it actually works with GenServers, supervisors. And then obviously, yeah, Elixir support's great. Like I said, it's about 800 kilobytes when you compile it down to WASM. Stuff that's missing doesn't have quite exactly full OTP support. There's a lot of things that are weird, you don't actually need them, I think, because if you're compiling Elixir just never touches it, or you're just not doing this weird thing that it requires. I'm trying to think of a good example, but there's some built-in ports inside of Erlang that you probably just will never touch unless you're doing something specific. And so until I write an example and find out I'm missing it, I won't come across oh, I'm missing this thing. There's not a good checklist of here's all the possible everything so that you can write your own Beam VM. It's kind of have to just look through all the source code and to figure out where everything is. One of the other things is I really want hot code reloading to work, which I don't know exactly how this is going to be possible because I'll get one giant WASM module in the end. And so I need to either generate a bunch of smaller WASM modules and swap those out, this all because of WASM problem for hot code reload, at least in the browser, or in WASM time or anything that's running WASM. There's a lot of BIFs. Let me just mention this. I've mentioned the word NIFs and BIFs. BIFs are built-in functions, and NIFs are native interface functions, I think is what it is. It's something kind of sounds the same, but it's different letters. Everything used to be BIFs. So everything was when they wrote the VM, anything that had to get down to the OS level to do something like spawn a process or even just do math, right? All those things that actually do hard work on the processor were BIFs. They're built-in functions. So if you've ever done native JavaScript development. You like call a function and that function calls some native code. That's the BIF. NIFs came around because they were like, well, we want to be able to at runtime be able to swap these out to change behavior or allow users to add behavior that is like efficient, like get down into like native machine code that's running in the process rather than like having a port. Yeah, and then a lot of what's missing is also just performance optimization. We'll get into it a little bit, like where this is performance-wise, but obviously the Beam has been around for a very long time, and they've optimized, and they're very fast. Like it's crazy how fast they are, especially when JIT was added. It added another like I can't remember 30 or 40% or some huge boost in performance. So yeah, and I'm not to the point where I can even think about JIT yet. So there's another kind of layer on top of this. Like once you build a VM, and then you're like, well, now I want to like expose this VM somewhere, like in WASM. There's like an interface that has to happen where the VM compiled to WASM is kind of agnostic to where it's running, but JavaScript has a bunch of JavaScript concerns like the DOM. And so there's this glue code in the middle that I just call the Typhon client that is the thing that loads the WASM module and then has this idea of saying, I'm going to create some what I call a callback in JavaScript, but it's basically saying like create some process in the VM and then hand me back its a PID that I can use as a reference to that, so that other things when they call that they actually send it out to JavaScript. So rather than using any of the like message passing stuff kind of built into WASM, it really makes it so the Elixir code or Erlang or whatever doesn't even know it's talking to JavaScript, and the JavaScript is really just dealing with like message passing. And so yeah, you create a callback, you get a PID for it, and then you new up some things and like hand a PID to it. So it'll the API is kind of still solidifying, but it's something like this, right? You load WASM, which gives you like your VM handle, and then you say, hey, load this module, load that module. Then, just go through and say, load all the modules that exist that I want to use. I have some like essentially auto loading that I'm trying to work on, so that you could just load one, and if it requires one, it will automatically go to load another. But for right now, it's a lot easier to just create the list of things that need to load. And then spawning a process, like meaning spawn one of these modules off, send something to one of the processes that spawn off, because this will give you a PID back. Call things like GenServers, and then registering the callbacks is the way that you get kind of the actions that get triggered by the VM to call back into your JavaScript code. One of the things that's not mentioned here, but it will be showed in the code example, is WASM doesn't like run in your browser just like behind the scenes like a web worker. I mean, I guess you could, but for the way I'm running it, I have to essentially tick it constantly. I say I have a run loop that says, hey, VM, go tick one time, and it goes through and does some work, and then yields back to the JavaScript. So the JavaScript's kind of sitting there poking at it over and over and over again. So when all these things are happening, it's essentially part of this run loop with the main browser thread. Probably could move this into a web worker and then do that back there. That way it's less of a performance hog. But right now it's easier to do on the main thread. Yeah, as an example, here's some code. Don't take it as perfect because things have moved around a bit. But the idea is, you load your client in, grab the WASM from somewhere, init the whole system, and then this is where like, so you might have a bunch of these things. Theoretically, you would just have one. You would just say load my app called like counter. This is a bad example because Elixir dot, you would not want to put your things necessarily under Elixir. Well, actually, okay, the reason why this is doing this is an Elixirism. It kind of hides an Elixir, but when you create an Elixir module, probably know this in the behind the scenes, it's actually making a module called Elixir dot the thing. And so this is really like just saying def module counter. I really want to hide this, but then I want like it would not be agnostic to the fact that this code was Elixir when it was first compiled versus Erlang or something. Anyway, so then you do something like registering a callback. You'd grab a PID out, and then that PID, well, in this case, it's saying like, go send this thing some message. This is actually wrong. It should have like an increment and then a subscribe. But the idea is that this would pass the callback as like the from for that cast, so that when it says, oh, I did the thing, I'll send this back to you later, that it's essentially just sending this callback a thing to say, hey, yeah, here's that term or something that you just asked for, which in this case would be like, you've incremented the counter, now that here's the new count. And then we just print it out here, which is why this is showing when you do this at the end where you say, okay, now run this thing forever, this will just print out once. So, going to skip over most, I think, this stuff, but it's basically just the bytecode and how that works. And the reason I'm going to skip over is there's an example at the end. We'll just play around with it rather than go into any of the stuff in here. But yeah, like I said, there's about 185 opcodes as of OTP 29. I've implemented about 127 of them. And then pattern matching has been the bane of my existence. The memory model is interesting. Zig actually just deals with this really well because Zig has like a core part of Zig is just memory allocators. And so it's actually relatively easy to say this process gets its own little arena allocator and can do whatever it wants with it. And then when the process gets destroyed, just kill anything that arena allocator had. So the memory model's actually been pretty easy and considerably easier than dealing with things like the scheduler. Let's see. I already explained the MIFs and NIFs. Yeah, and a testing strategy for this was mostly just unit test the heck out of everything. You need integration tests. Like sometimes you just don't know what to unit test until something breaks in an integration test. But it's really hard to figure out what exactly went wrong when you're just running an integration test and you get something like the whole thing panics. So definitely, like I had to lean on just doing just a boatload of unit tests. And then one of the other things was comparison tests. So basically, I just have like one of the examples of the tests I have is something called REPL compare, and it just starts the Erlang REPL and like sends it some stuff, and then asserts that like when my REPL gets called, it sends the same thing back. So essentially, it's kind of like the way LLMs are being trained now, where they're like, you just have to respond like this other one responded, and then you'll be smart too. And so I'm just doing that on a testing level. And then, yeah, debugging. I just gotten to the point where I started having to actually learn how to use debuggers, and it's pretty hard, but I'm going to end up having to get down into this level, especially to fix some of the weird performance quirks or crashes that happen after being up for a very long time. Yeah, the key thing though is just getting, especially we'll get into it later, getting Claude or AI or you to just write a bunch of very minimal reproduction cases of every little problem instead of just saying, oh yeah, I fixed it that one time, and so the problem's probably gone. It's really critical to have little tests wrapped around each one of these cases. But we'll get into also, if it's just performance we're worrying about, Erlang has its own benchmarking suite called eStones. They give it like a score. And I guess they introduced that in order to like know if they've introduced a performance regression. So that was a really interesting thing to be able to rely on, is just like say, well, if I can get the eStone test to pass or to run for my thing, then I can kind of tell, apples to apples, how well I'm performing versus Erlang. But I also know that I didn't introduce any performance regression. And I watched this number like tick down slowly, and it's been really nice to get down to a reasonable number now. And then, yeah, WASM also, those tests also need to run in WASM and WASM time. So I need to run in all the different environments that I can run WASM in and know whether there's some weird overhead or like maybe it works fine natively, but in WASM it crashes out for some reason, which has happened recently a little bit. There is a potential for JIT compilation. I'm just not there yet, but I do think that, especially running in WASM, it's possible that I could just JIT into straight WASM. So one of the interesting things is when Erlang first introduced JITting, they only targeted x86. So there wasn't like ARM support. I think there is now, but like there wasn't in the beginning. But they had a bunch of other architectures where like, okay, well, now we got to do PowerPC or whatever, other architecture we want to support. Or maybe at the time there was probably 32-bit machines still running around. And so the nice thing about WASM is if you JIT to WASM, you only have to JIT to one architecture. Theoretically, WASM's a moving target though. One of the interesting things though about WASM that was cool is there is a tool called Binarian, and its job is to take some WASM input and then optimize it and give it back out optimized. So it's kind of like the optimization step in LLVM where you like get to this intermediate language step. And so like if you're, I think what example, like Rust compiled to LLVM, and then you also had some other good language that compiles to LLVM. Like none of them. Anyway, so say you had C# compiling to LLVM, whatever, I don't know, something, right? You have a bunch of languages compiling to LLVM. If they all get to the intermediate language step, the optimizers are all written at the intermediate level. So they all kind of take advantage of the same optimizers. And so that's the cool thing of Binarian. If you target WASM, you get the optimization step built in. So that was actually a pretty big boost in performance. And I really should like run 2 different benchmarks to show the difference, but it was pretty amazing how much it sped up the code. Yeah, Yeah, and then there's another weird thing is that originally WASM only supported 32-bit memory, and it wasn't until very recently that it supported 64-bit memory. But the problem with that is that not like I think it's WASM time doesn't support 64-bit memory without a special like flag or something. Like there's other things you'll find that if you're trying to run it, a module that uses 64-bit memory, you can't just run it. So it's possible that say like Cloudflare workers, if I wanted to run this WASM module, couldn't run it because I need 64-bit memory and they may not support it in their runtime, like because they're on some old version of WASM time. All right, so live demo. Let me see if I can get this to work on Zoom. I am just going to share this whole screen because it's me a lot. Actually, no, I won't. Hold on a second. I had all these things set up and the Windows made me restart to use this camera. All right. We will just do. Can you see? You can only see the web browser, right? Not the terminal.
I see. It says you started screen sharing, but I don't actually see anything yet.
Oh,
now I see the browser. This is live
just
demo.
the browser. Okay, just the browser. Okay, that's annoying. Well, I want to be able to select like a region, but all right. We're gonna do. All right. Now this is a pretty complicated example. So if things break, I might curse a bit. Okay, so this is a giant VM inspector for the browser. The idea is, you load some precompiled modules here. So if I grab this, you see this is all Erlang for now. Theoretically, I could do Elixir for this, but it was easier to just target Erlang. You could actually write it because behind the scenes, what this is actually doing is it's grabbing Beam ones that already exist. But if you were to like write some code and hit like save, it actually goes and like uses the Erl-C to compile it into Beam and then make it available. So it's not compiling. I'm not compiling Erlang to Beam. That's actually a really hard problem. Running the Beam is actually easier, I think. What we'll do is do something like factorial that's like super easy. And we say load it. And then we say, we're going to grab this. Oh, please do it. There we go. I thought I might have broken this. Anyway, so what this is doing is this is showing the actual Beam bytecode for this little module. And it's actually pretty interesting because it's conceptually just like super small and really convenient to like look at, because especially if you put in some highlighting here to see that like label here is like the opcode and there's an argument of one and another label, another opcode, right? And then and so if you I hooked this up so if you hover over down here, you can kind of see what's mapping to what, and then vice versa. And so we put it kind of low and say, actually, we'll just step through it. Right, we step through, you can see reductions have counted down. I'm gonna make this a tiny bit bigger. So you can see we have 4,000 reductions we can go through. We've used one of them. And so we just keep clicking through. You can see we keep stepping through, step through. And you can see down here, we have this one process running. And what I'm gonna do is I'm just gonna let it just run through. And it's just doing its thing. It's just actually like calling functions, executing opcodes, passing arguments in. And the registers in Erlang were actually really easy because I've done some kind of Game Boy VM from scratch in C# kind of classes and stuff. And opcodes, registers are like very simple. They're like, oh, it's a 32-bit number or 64-bit number or something. But these registers are like much more complicated because they could be any term. So they could be a PID, they could be an entire list of 1 million elements, they could be like anything. And then there's also a Y stack, which I'm not going to quite go into. The idea is, this is where the scratch pad of like what these opcodes map to, like which register to pull in and then what to put in it. So you can see here, like this is referring to X0 and this is referring to X1, things like that. I'm not really trying to become like an expert in exactly reading this or writing this by hand, so I haven't even tried. But conceptually, it actually looks a lot simpler than like x86, 64, or assembly or something. So you can see anyway. So we got the 120, which is what factorial 5 is. So if we make it a little smaller again, you can't go very high with this because it gets to be a very, very large number. So instead, I'm going to run this, bump it up pretty fast, and say just go. And actually, the funny thing is about this, the slowest part about doing this is just getting it to render in the browser. Like it's waiting a long time just to like move things around, whereas it's actually much faster just in the background. Yeah, so it's a very large number. If I throw something super large in, it'll probably just crash out. It won't crash out. It'll get a very, very giant number and probably not be able to put it in there, but we'll see. It does support big num, but it'll take a very long time. Like this we are not going to wait around for. Anyway, so that's the example here. The other thing I want to go through real quick is, you can see like this module registry and atom registry and stuff. Those are really interesting because, obviously in here, right, like in this module, I've defined a couple things like fac here as a function name and in as a variable and all that kind of stuff. Well, those aren't exactly the same, but fac itself is obviously being referenced by somebody else. It gets turned into an atom. And so in this module, there's going to be somewhere fac is an atom. But when you think about it, if two people compile, their own BEAM files and they both use the same term, they don't have the same number, right? They don't map to the actual same like number value in behind the scenes. And they don't store it in this table. They don't store it as like the exact term. They store it like as an ID, like an index into a big list. And so when you load multiple BEAM files, one of the steps that has to happen is you have to essentially you have to load them and then translate all of the atom indexes into your now global atom registry. So that was kind of interesting. And same thing with the module registry. So if I load like another one of these, you'll see the module registry keeps track of every module that's been loaded, so it knows whether it needs to go load it again or whether it's already loaded. So we can real quick, actually, I want to try and run a little more complicated one. I'm going to reload here. It'll dump all of the things that are loaded, and it will run something like the supervisor. It's an interesting one because this is actually much more complicated because it's the real OTP supervisor. It does like start link and all that, and it's going to spin up like workers. So we'll see multiple processes go. And so we just call start link 0, run. This one will get a little hairy because there's a lot of stuff going on. So it's just interesting to see how much has to happen in order for like a simple supervisor to just start something. And I think this one isn't even, oh yeah, there's a worker loop. So it is constantly going to keep doing things behind the scenes. And you see when it turns yellow here, that means it's in wait. So it's just like, there's nothing else for it to do. It's just going to sit there. And so the green one here is the actual, let's see, what is this? Hard to tell. I think this is the supervisor and this is the worker. Anyway, yeah, it's going to keep going. And also, you can see it's bouncing back and forth between, I don't know why it's saying unknown there, but you'll see it'll bounce back and forth between reading a byte file from like maybe some system library like gen, or from, I think, supervisor itself has one. There's a bunch of like system binaries that it'll read from, and then it'll start, loading this one back, and it'll start. So it's bouncing back and forth between modules. But actually, this one takes a very long time to even go. But the counter is do counter server. And if we do something like start link with 1, so it takes a parameter of like where to start its counter. So I'll give it like 10, and then say go. And so theoretically, it'll go and go and go, and it eventually will say, okay, my count is now 10. Like internally, I spun myself up, and then now I have a count of 10. I just recently started using this on this Windows PC rather than my laptop, and luckily the Windows machine is a little faster than my laptop. Hopefully you'll be able to get to the end. There. So if we do something like now, we say something like, I'm just going to say get, so we can just move on. So I'm just going to get the count. So it should, because we set it with 10, it should just bring back 10. So just return us on the Y stack by 10. Oop. Yeah, so that was it. And you go through the same thing, and you do something like increment, decrement a few times, then eventually you get back whatever count accumulated in it. But it's literally like storing those in memory. And you can see like the ones that were doing the work, like when you call into it, there's a little process that's working, but the thing that's actually holding the state is this one. So that was kind of interesting. All right, let's move on back to the slides for now. yeah, so we saw there is we're loading Beam files, viewing the atoms and all that kind of stuff. So you see how the code works and then stepping through the execution. And obviously that's working in a browser, right? So let me see. Yeah, getting the VM state out of the VM was actually pretty important to me. Like normally, obviously, like you don't get access to that low level stuff inside in most VMs, but I really wanted to be able to do that in these examples to debug it. Like I couldn't do that. It was going to take much longer for me to actually develop. And so I don't know if that surface area of like being able to get access to that low level opcodes and what step you're in is actually critically necessary, but I'll probably leave it in just because it's fun to play around with. And we'll see another example where it actually does kind of become useful. Yeah, and then the outside, the whole shell of everything I was running obviously was like TypeScript and like SvelteKit, I think, to spin that all together. I did a couple different iterations on that, and that was like initially it was actually just a simulator that I wrote in JavaScript to just see whether I was doing things the right way. So it was completely like in parallel with the actual VM operation in Zig, and then at some point I just converted over the back end of it, meaning like the thing that's running the logic of it to really just use the WASM module. Yeah, so this is, I'm going to show this one. I'm still working on it. I was really hoping to get it done by now, but it just has been super, I think it's a lot more actually intense than the inspector because there's a lot of things actually going on. So what in my head, what I really think about when I think about processes running on a VM is like cells in like an organism or something. And so the idea is that each one of these processes, I want it to be a little cell in a game and have there be food, and then like you spawn in. Oh yeah, it's already crashing on me. This one's pretty hard. So you spawn in like a carnivore, and its job is to eat the herbivores, and the herbivore's job is to eat the little yellow cubes. And so what I want is this thing to be a scale up and say, okay, there's millions of processes. Let's see how much we can get to. So I wanted to show it, even though I couldn't get it working, because I like the interface that I ended up landing on with this. And this was critical, right? It's a learning tool. The idea is to be able to see like how much memory these things have, what PID they are, and to be able to like go pause it and literally go inspect the VM and do something, make it literally crash or something when they get eaten or something and see what happens. And then maybe give some like a supervisor so they can like be immortal or something. Yeah, so that's just another little example. And then so by now it's probably pretty obvious that the entire presentation is actually running in the same VM. So all of this is actually running in live view. So behind the scenes, there's Elixir running all of the slides. And when I'm actually hitting next and previous, there's actually message passing going on from the front end. So replacing a WebSocket, essentially message passing to a WASM module, right? So this is a really terrible visualization that I do not like. But anyway, the idea is, all of this is just live view now. I could literally just stop the server that's actually running this and keep loading or keep clicking next, and it would still keep working. So this whole thing is just, like this is actually in a live view with a little counter, incrementing and stuff. Yeah. So how do we develop this stuff? And also, I'll get back to it if we want to look at it more because we'll probably have a lot more time because I'm going a little fast. And we can go look at the code for that because I think the live view code is actually the most interesting part about this. So the AI workflow, I started out doing all of this with Claude code because this is like maybe 3 months ago. And then since then, I've switched to using open code just because open code supports multiple models. Like I want to also use Gemini, and I was using ChatGPT, but I stopped recently because with Gemini being so cheap and then Claude being so good, those are the only two I really need. I don't really need ChatGPT for anything else, but theoretically, you could run like your own Llama models or something like that. And you can also use something like you could set it up to communicate with your own Ollama, like locally hosted stuff, or like whatever the LLM router service that exists. So the nice thing with open code is it just supports a bunch of models. And then recently I also started using my open code, which is really just like an architecture put on top of it to add some agents that have specific roles. Like if you're doing front-end UI, it'll grab Gemini to go do that because Gemini is really good at front-end UI. And then also something that I'll show when we get to the kind of source behind all this is I'm using this thing called beads to do task management, which is pretty critical because for a while I was just keeping just giant markdown docs in the source code. And it's really hard when you say something like, hey, go generate this, 1,000 1,000-line markdown file, and then later you want to come back to it, and you're like, oh yeah, that's kind of out of date now. And you, in order to see anything in it, you've got to either like randomly select windows and hope that what you want is there, or load the entire thing in your context and blow it all up. And so the beads tasks are essentially a little mini database of, tasks like in Pivotal or something like that, that can have like parent-child relationships and labels, and you put them in progress, close them out. They actually have like Jira and I think Linear and a couple other like tie-in support, so you don't have to have your own. You can like have them tie in remotely. So that was pretty critical to actually getting a real workflow where I felt like I was steadily able to, like, when I noticed a bug, I guess I just make a note of it in beads and let's move on and go fix what we were doing now. And then later go, what's the next highest priority thing for us to do? And it would just list out the 5 things that are unblocked and we can work on. So beads, I think, is a pretty good organizational tool. Yeah, and then the other thing is a lot of human input. I tried for a little while to just say like, go run it, and hope that it settled on a solution. But often, I think I have a note in here. Well, it's somewhere in here. Claude will lie to you and say that it did something and it actually doesn't work. So there's a new pattern in AI called Ralph, which you might have heard of, which is basically you take this really dumb AI, you give it a big complicated task, and then you let it run over and over and over again until it like gets a solution that's viable. And while theoretically that's true, it takes a lot of, you have to set up the harness that can determine whether the thing it came up with was what you actually need. And so all the work becomes like that, right? Like code review or something like that. And there's a couple times where I told this thing, just go for it. And especially with my open code, it has automatic kind of prompting to tell it, just keep going, like down your to-do, don't stop. And it'll do things like, it ran into a problem with the cell game not working in some weird reason. For some weird reason, I come back and all of a sudden everything's working beautifully. And I'm like, oh my God, finally got this thing working. And it wasn't until the next day I learned that it had decided it couldn't get it to work. And so it made a mock implementation in JavaScript. And so, yeah, you really got to keep an eye on your AIs. But things like boilerplate, amazing for like if you already have an example and you just don't want to type it all out again, you can say, go make another thing that looks just like this thing and it'll just do it. So following established patterns. Having it read specs and documentation for you is really great. Oftentimes, specs get out of date, so you find out you're looking at an old one, and now you got to read another doc and another doc and another doc, and you can just have it fan out and do all of them at once. One of the things I found really, really useful was getting it to just write tutorial series on things, because finding a individual Beam tutorial that's at a certain level is already kind of hard. There's only a few of them that are good and up to date and whatever. But so finding the exact tutorial I needed on the internet to do something like this is almost impossible, or it is impossible. It's not there. I've looked. But you can get the AI to say, here's a very targeted thing I want you to do. Like, make me a tutorial on doing this thing with the Beam VM, and also use Zig if you ever do a code example or something. And it can just write really good tutorials that are good enough. Like, you just have to be able to call BS when you see something that looks made up or something. So you do have to be careful, but theoretically you should already have been doing that when you read regular tutorials you find on the internet. So just hone your skills, I guess. Yeah, there it was. Faking solution. Yeah, so AI struggles with novel architecture decisions. Like it's not really going to come up with a new pattern or something that you just, nobody's ever thought of before. It's just repeating things that exist. And so really to come up with something novel and to really glue things together, it kind of relies on you recognizing those patterns and going, no, you shouldn't do this. This already exists. It also really struggles with design patterns, like even basic design patterns, and being able to predict that, like, I shouldn't do that because I'm gonna have to update that in 20 different files later. I should, make a function that does that. AI doesn't do very well with that kind of stuff. Partially because it was sampled on all human code, and people are just generally not good at doing that, and so it just does that too. Yeah. So what is the future of this VM? Obviously, I want to finish it get it full OTP support, get the performance on par. We'll do it in a second. We'll go over what the performance is, but I want to get it, at least on par with Elixir and Erlang. WASI support. So right now, because of the need for 64-bit memory and the way the WASM time and WASI work and stuff like that, I don't have real WASI support. WASI is the WebAssembly system interface, I think it's called. It's basically like if you need to do like a network call from WASM, the host kind of binds a function that says, here's the the network call function, and whenever you call this inside of WASM, you'll just call my function and do a network call. And so I need I want a way to handle all of the core things with WASI, and that way when you do something like run in the browser, you're really just like saying, okay, well, when you do an HTTP call from, WASM time, we'll hand you, WASM time actually has a way to give it a handle to a request function. But in the browser, it's something like literally just call fetch. And so you need to I need to get all that part working. Right now, a lot of it works obviously because the client works, but I can't do something like make a network request from inside of WASM without having to make my own function to bind it. And then distribution protocol. That was one of the kind of critical things about Elixir or about Erlang, right? Like distributed is the whole point. And so I want to get down to a level where I can do some kind of I think it's what's it called? EPMD. I need the distributed part of it, like the ability to actually run clustered, elect a leader, do all that kind of stuff. Whatever things. I haven't even got it into that part yet, but the ability to spin up maybe three. If I could open up 3 tabs, and then they all just connect to each other through some kind of mechanism, because they're all running on the same page or something. Maybe they can communicate, to each other by putting something in session store and then doing some kind of WebRTC connection in the back end or something. Yeah, and then component model stuff. That's again just a WASM thing right now. I am starting to do WIT definitions for this, but a lot of it because of the memory, the 64-bit memory, and how WASM is. I haven't really concentrated on making this the best WASM. I'm just trying to get a working VM right now. And then so some potential use cases for this. Obviously, browser-based Elixir is working, and the best part. If you think about it, the cool thing about that is you could do things like have offline capable Elixir Phoenix apps where you ship a bundle down and say, when you go offline, just run this little piece here. There were some people doing, what was it, Live View native, and they needed to connect to an Elixir backend, and they're like, yeah, when you go offline, what do you do? You can't render anything. Well, if you could have a little WebAssembly module that just runs locally on the phone, you don't have to try to run the entire Erlang VM. You can just run a little bit of WebAssembly. And then embedded systems. We'll go into a little bit why embedded systems are, why this is capable of that. But if you could run this thing on not just a Raspberry Pi, but something like an ESP32 that has something it's something like 512 kilobits of memory. It's or kilobytes of memory. And some, maybe anything less than 2 megabytes, you're not running a full Elixir VM, or Erlang VM. Yeah, sandbox code execution. You just get that anywhere you're running WASM, and then education. It's just fun. So even if it doesn't get any of that stuff, it is a lot of fun to learn how Erlang works, how the beam works. Some challenges. The beam up until I guess 10 years ago was kind of stable, but ever since Elixir really, took off as much as it did, I guess, it seems like they put out more and more big changes and more just iterations in general. And so there are things changing. And so as I'm developing this, I have to keep up to date. And I really don't want to support the older browser stuff. By the time I get this really working, OTP 32 is out, I really don't want to be supporting 28 anymore. And so the moving target part is gonna be a little bit hard. NIFs are a little bit weird in WASM. I mean, theoretically, the WITs can essentially act as the interface for your NIFs. One of the things I didn't go into in here, and one of my goals is it has to support Rustler and Niffler, or no, Niffler. It has to support Rustler and Ziegler to write NIFs. And the interesting thing is both of those languages do support WASM, so theoretically you could have as their native part of code that gets generated could just be another WASM module so that it does actually work in the browser. And then, memory constrained devices is just, embedded devices. And then debugging WASM is hard. We're finding out that at work. Getting the community to help, it would be nice. It's also hard. I found that, I didn't put it on here, having more than one person using AI tooling to really blast ahead in a repo is probably gonna be pretty hard because AI loves to just rewrite everything. So I don't know how, in a world where, many people are trying to use AI tools to throw a bunch of code at you, it's gonna be really hard to not have giant merge conflicts or things like that, or just breakages that you just didn't detect because your AI code reviewer didn't find it. So that's a challenge. So It will be open source. So I should put an asterisk in here. I haven't opened it up yet just because I don't want anybody looking at my nasty AI generated code. But soon, theoretically, and at that point, it will be MIT licensed, so anybody can play around with it. Yeah. All right, I'm gonna just skip through some of these. No, let's stop on this one. I did find out Elixir has something like, sorry, the Erlang BEAM has something like 500,000 or 700,000 lines of C. And the other day I mentioned this to somebody that I was working on this project. They're like, how many lines of code is it? I was like, I don't know. But I was assuming it was many, many more lines of code than the C that's in Erlang. And it turns out it's not. It's only 30,000 lines of Zig, of non-test code, of actual like VM code. So that's kind of interesting. Yeah, about 3 months of active, like the AI is developing this. I was developing it for a little while before that, but didn't get nearly as far as this did. And like I said, make sure you pull this up. It'll come right back to this page if I reload it, but we watch all the Beam modules and stuff load in. The Typhon binary itself, or the WASM module, is 801 kilobytes. And actually, one of the things you can see when I reload this, I'm not gonna, you don't have to really see most of this, but all of these files are the Beam files loading in from the network. So behind the scenes is a JavaScript, a Vite server that says whenever you request this Beam file, just go into the actual like Erlang or Elixir install directory and just give you that file. So that's what these are. I had it working dynamically right now. It's like I have to have this list of things to load for some reasons, but Erlang doesn't like to wait for your module to load. Like it says load it, but it's not truly asynchronous. Like it doesn't want to sit there and wait for it. Anyway, yeah, this slide's a lot out of place. I should move this forward, but WASM's gonna be a little weird. Yeah, and then resources. I would say all these things, right? Like the Beam book, all these places to look. In reality, I found that for the most part, I never go to sites anymore. I just ask the AI, summarize this thing. Every now and then I'll say, give me a reference so I can go validate whether you're saying is true. I find less and less that I'm actually going to these sites and actually reading through their content. I just say like, summarize it, combine it with all together with all the other stuff and generate me a big document that like tells me exactly what I need to know. Put references in there so I can link back to it. But yeah, I would say that I've started reading documentation less and less. Yay, it finally did it. It got me the Zig logo. Yeah, so I'd like to, thanks Claude for writing all this, and thanks Micah for hosting this meetup. Are there any questions? Also, this is my really cool AI logo again. So it looks like one of those things you used to get back in the day in a sticker machine. Like you get it and you'd roll the handle and they'd come out. I don't know. Have you ever seen those?
The tattoo.
They go with the tattoo or the tattoos. Yeah, exactly.
You get this on your arm.
I will totally get that temporary tattoo.
I do have a question for you, and selfishly, I don't want to ask you this question, but maybe I should. Well, I mean, like, because then you might actually do this. But have you thought about reaching out to Brian Cardarella?
Not yet. I don't. I did. Like I said, I mentioned LiveView Native because some of the things that he's done, I thought this would be really critical. Like something like this would be really great for. I think they even mentioned Atom VM at the time, and so it would be something to probably do once it's in a state where it works.
Sponsored several projects like this.
Oh yeah, you're talking about our sponsor. Yeah, probably. That would be good. So I am burning up in here. I'm trying to quickly turn my AC on. It's like 80 degrees in here. Sorry, Florida. That's really hot for me. But yeah, and then also just for fun, I also had Gemini make me a chibi version of this, which I think is even better. Yeah. But
that looks like more like a language logo because it looks
right. Yeah, I started out with the other ones and I was like, this is a little too. This looks like LLVM or something, right? Yeah. This looks like Go.
Yeah, it's like the Go logo but better.
Okay. So I am going to stop sharing this and instead, because now we're done with the presentation part of the presentation, I'll just share the entire screen. I have to, actually, do it this way.
I thought you said you were running Windows.
I am running Windows.
That's Linux.
Well, it's Linux and Windows. The issue is my framework laptop has this issue where it will just randomly freeze up at some points I don't know if it's going to like a sleep, like not a sleep mode, but it's like a battery saver mode or something. Even with it being plugged in, and if it did that in the middle of a talk, it'd be really hard to recover from. Anyway, let me. I just wanted to call out a couple of the cool things about this repo. Uh, so one thing was the tutorial section, like I was saying, and I think what I'm going to end up doing is getting these to just publish out to a doc site somewhere. Um, but in docs, so initially, like literally everything I was doing was in this giant folder called docs, and this was like all the planning, all of the tasks that were going on, and all that. And I settled to like, I'll put some planning docs here, and then the architecture doc are the long-lived like canonical source of like this is the current architecture of the thing. And then I have a section on tutorials, which is like unrelated to this. Like a lot of them don't even mention Zig or this project specifically. They're just like how do NIFs work and what's the entire Beam instruction set like lifecycle look like and garbage collection and how do supervisors work. So these have been really useful. Just in general, having a docs directory and having a method for saying like knowing that like these docs in here have to be pristine so that when you do something, it does something like, oh, I changed the like I implemented there's a garbage collection. What was it called? It was a guy's name. But there's a very naive garbage collection algorithm that it implemented, and I was like, yeah, just update that. I mean, I should be able to find it because it's literally in the GC doc.
C.MD right there.
Yes, the Cheney doc or the Cheney semi-space copy and collector. Yeah, that's why I could remember. Anyway, it's called the Cheney's algorithm or something like that. And it's just like a super simple garbage collection method. And so initially I didn't have any garbage collection. So like everything worked, but like if you did anything for too long, it would just crash because it would like run out of memory. And so when I implemented this, I was like, oh, hey, go add a doc called, or I think GC already existed. I just need to like update it. So anytime I'm doing something that changes the architecture, you say, go update your architecture docs. A lot of these other docs these other directors are now out of date because, they're like plans of stuff to do or like tasks, and I've now completely replaced that with beads. So actually, that's the other cool thing to show. So beads itself. Actually, let me first look at here. So there's a .beads directory. Most of the stuffs get ignored. The thing that is like the canonical source of truth is this giant JSON C file or JSON L file, which is like I think it means it's every line ends in a comma or maybe it doesn't actually. Maybe it doesn't. It's like a new line or something. So basically, it's so that it's like append and you don't mess with the line above it. And so all of your tasks are in this one big file, and you would like check this into your repo. And then when you pull it down, you do like BD init, and it creates this little SQLite database. And then that SQLite database is what you're actually interacting with. So when you say something like BD ready, and it'll tell you like, here's all the things you can work on. These are all coming out of the database, not the JSON file. And then there's a sync command to say like, hey, flush all the stuff that's in your database that you just added, flush it to your JSON-L file so I can like make a commit. So yeah, this has been pretty critical, but with VS Code, and there's some other tools, there's actually some really cool TUIs and stuff like that to use these two. You don't have to switch to VS Code. You get like, a way to like edit these and like look at them. And I think some of these, like, especially if you look at the epics, will have like all these parts to go along with them and like which ones have been closed and like which one's currently in progress. I really shouldn't keep them in progress, but I don't forget. Claude forgets to close them out, and I don't catch it before it makes a commit. But theoretically, like I think my practice of doing it is that every commit, it should be like closing an issue out. Theoretically, you could have multiple commits that don't, and they leave one open. But like at the end, theoretically, it like closes it out, and everything between the last open, when it opened, when it closed, is all related to working on that thing. Still trying to figure out what the best.
I think this is really the interesting part to me. Like everything you've done is absolutely fantastic. Don't get me wrong, but like I'm looking at this going, okay, you've implemented a rather large and sophisticated project, around 30,000 lines of code with a garbage collector, yada yada, with a VM. Can you talk just a little bit about your process of? It sounds like, because you went kind of fast. It sounds like you're having the AI write a tutorial and then having the AI write an architecture doc, and then you're referencing those to implement things, or are you strictly going off of this Kanban board, or like how are you organizing all the tasks so that you keep the AI on track for a project this large?
So I would say the tutorial docs are more useful in the beginning when nothing worked at all and it was still coming up, or when I go to implement something that's like a generational garbage collector or something that's a more complicated one. Then I'd get it to write a new document so I can actually understand, because you can't guide it to do the thing unless you at least somewhat at a high level understand it. And you definitely can't code review it. But it also becomes, those documents become a really good source for it to look at. So those tutorials are also for it to look at later. But they're for me initially, but they also serve the purpose of later when it goes off the rails and starts implementing something it shouldn't, you can point at those tutorials. I don't generally want it to read it because there are a lot of files and I want it to keep its context smaller than that, not blow out too much. But you could use it for that. But I'll say like for the most part now, because it's an established thing and there's a lot of tickets that are ready to work. Like I mean, these are just the not closed ones, right? So this is like all stuff that could get done. So all I would have to do is if I do like this is just open code. This isn't using my open code because I moved over to WSL. On my Windows side, it would be using my open code. But if I say something like what's theoretically the agents MD should tell it to use the BD file to know this, right? So it did. It said it goes and does this. So here's the things you should work on. Right, so this is kind of where I start when I'm going to work on something and now this kind of relies on that you have to have these things have children and relationships and good labels and stuff like that, and enough context baked into the story. You don't want a giant book of it, but enough that when it hits it, it goes, oh, this is what that's all about, and then this can basically self-determine. And then as you're working on stuff, you just constantly find new little things that have to happen. Like it'll say, oh, there's actually a bug in this thing. And I was like, oh, we'll go create 2 issues for that. And then let's move on, right? Like we'll temporarily get around that, make 2 issues for it. We'll come back to it later and we'll move on. So that's kind of my process now. It's more like a kind of 50% done project. But
so I guess my next follow-up question to that is, do you think just using tutorials could have got you to a 30,000 line repo with AI, or do you think that beads was like super instrumental and you wouldn't have been able to do it without it?
No, I could have done it. It was just becoming, it was taking a lot longer because the number. I wish I had an old version of this that I don't want to go check it out, but I do have it in code somewhere in here, like from a few weeks ago, where there's going to be like 500 task file, like markdown files that are named like I had a naming convention of like 00.00.1 or something, right? And it would be like, so you could create a task called 01, and then if later you found out there's extra work to it, you would put a 01.01, and then so you could have so many number of children tasks, and that was how I was essentially like making dependent tasks. But then like, how do you do like cross dependencies or like, so I was just having to do a lot of manual management of it. I was blowing up my context way too fast with it, and it was just generally hard to know that those docs were up to date, or for Claude or some AI to go look at it and tell me whether or not like if I said what's the next thing to work on, it had to like look through every doc, or I had to keep an index doc that did that at some point. And so having it in a real database is pretty critical to moving fast. You could do it. Yeah, in a CLI tool.
The other question of this is, so this is really awesome that you're checking it into your repo and that all your stories are here. And obviously you haven't tried working with someone else, but do you know the docs talk about like conflict resolution or anything? Like if you had multiple people working in the same repo and they were all working out of the same database, would they be collaborating each other, or are there ways built into this to kind of mitigate that?
There are a couple ways. One, I think that because they're all individual lines that are changing, theoretically, conflict should be easy because they shouldn't change position. So any new additions will be individual lines in that file. And if somebody like adds a label to one that you completed or something for some reason, and then they check that in as part of their commit, which would be a little weird. I guess you just need good Git hygiene for that to not be a problem. But if it happened, right, it would be that one line that was in conflict. So that's probably part of it. But also imagine that one file is part of like a 40 line or 40 file commit. It's a problem.
Shit. So, I just realized. Okay, yeah. So the JSON-L file is really like a write-ahead log, and then when you download the project, you instantiate your database and use the write-ahead log to instantiate it.
Yeah.
And so everybody has their own copy.
It's like a write-ahead log, but the problem is that a write-ahead log would be like everything above it's never changing. It's immutable, but it's not, right? So it would be nice that, now that you say it, I haven't looked at it close enough to know whether that would actually be really convenient. But I don't think that that's how it's structured. So like we can know because I can like grab one of these. Yeah, it's only in here. Each of these is only in here once, right? You can see it actually in here, right?
Okay, so it does mutate the lines. Okay, yeah.
Right. So there could be, but here the other thing is that if you by default if you run BD sync, that does a bunch of things. It probably just did some. Oh, and luckily it didn't actually detect any changes. But it will literally make a commit. It'll like flush your database into that issues.jsonl, and then it will make a commit that's like BD sync, and then it'll literally push it it like does all, it's like a git commit or a git hook or whatever. And I really don't like that flow, and so I actually tell it not to do that. But that only works because I'm working by myself. But I think if I wasn't, then you would kind of have to do that, so that every time you're messing with that thing, every time it runs sync, you would just get updated by whatever there's some random person is doing. But if you were on a branch, it wouldn't, right? So it's like there's got to be other ways. Like this is not a perfect solution for a large team, but that is why like they do have integration with Jira and stuff. Like it's Go code, so it's like
it's a really great solution. I think the thing that would be neat is if it could connect to like a Postgres that was centralized, and then everybody on the team could use that shared centralized Postgres.
Yeah, which is what I think is happening. I haven't played with it, but like it was like the day I found out about this, I joked with Micah about, hey, should I just be using Jira? And then like a couple days later, or a week later or something, they added Jira support. And I think that's what they're doing behind the scenes when you do that, is that they just stop using this and they just say, no, there's a centralized database of issues. So yeah, that would actually be the ideal. But that is the point. The reason why it works at all, it's not because there's a local file, because the other thing I have to tell Claude not to do is don't go in this file and edit it by hand. But it keeps wanting to do that. I don't want it to read it; it's giant. But I also don't want it to edit it by hand and screw it up. And so it really shouldn't be here. I really rather not. But really, what's essential is the like very concise CLI tool. And also, there's a like a BD Prime.
You could make a Claude hook that every time Claude tries to write it, it cancels it and won't let it do it.
Yeah. Well, yeah. Well, I mean, I'm using open code though. So I mean, it's enough to basically. Yeah, I haven't had to do it. It doesn't run it. Like I basically just tell it, like I do tell it to run BD Prime, which is like a command built in, which just tells the AI like, here is the information about how to do this. The problem is I don't want it to do this. So then after that, I have to say, no, don't do what BD Sync says. Do this other thing. Like you can run BD Sync to know how it's used, but also never use or run BD Prime to know how it's used, but don't do some of the things it says. But yeah, there's that. What else was there? Real quick, I wanted to go over the live view part of the code. Are there any other questions though? Because I don't know how much more time we have, like 30 minutes or so.
Yeah, I had a quick question.
Yep.
When you were trying to learn how to, like how the BEAM, like how some of this compiler or interpreter stuff worked, like were you going to the code base and saying like, read this code base, tell me how it works, or were you like going to books? Like what was your like most successful way of?
I think there was a lot of blog posts that were really useful. Like there's this one, like the Beam book is really useful. But again, right, it's super dense. It's better to get the AI to just say, here's a link to this thing. Tell me exactly what I need to know about this doc. That acts as a way of just querying it. I'm essentially using it like Google. The other thing, a lot of this is in pseudocode, and they're not showing you the C under the hood that is running this. So there's a lot of like, they describe what happens, but you don't really know the timing of it or exactly like the conditions of it. And so, yeah, a lot of it was just, I literally just pointed at the actual Erlang code on my local machine or like on the GitHub repo. Because like what is the thing called? There's an opcodes file that they keep. God, I can't remember what it's called, but it's got a weird ending. But there are files where they, in the Erlang source code, where they list out a bunch of things, and those things are really useful. Like what's every possible opcode, or what's every possible NIF or something like that. And those are the ones that I want to be able to point it at that and say, hey, like take that list and then cross-reference it on all the ones I support, and then tell me, what am I missing? And yeah, it's been hard because there's not actually a spec that is like published or something that is, it's not designed for them to support somebody else writing their own Beam. So the docs are like there, the source code is there, but you kind of have to just go find it. But luckily, also Erlang doesn't have a bunch of third-party dependencies. It would be much harder if they did, because then you'd be like, oh wait, how does that thing work? Or they really quickly take some C code and then they make a thing that can run Erlang quickly, and then they just run Erlang. So most of their actual library is just in Erlang. And conceptually, like there's actually, Mike will know this better, but there's like a really small surface area of actually the actual things everything else builds on top, like spawn link, right? It's like, and there's like a couple other things that are like, like everything else is like baked off of like a small subset of all of these core things. And if you could just implement those core things, then theoretically you have a full Erlang.
You just need spawn, send, and receive for processes. Because you spawn a process, you send to the process, and you receive in the process. Those are your primitives. And then for supervision, you need linking, and you need trapping exits.
Yeah.
And if you have those things, you can do almost, there's also a couple other concepts in Erlang/Elixir, like monitoring, but you really can pretty much, you can do supervision with the things that I mentioned.
I would suspect, though, monitoring is probably based off of just linking. Right, like it's probably just some message passing that happens with linking.
I don't
like.
I mean, maybe under the hood, but I think conceptually it's kind of a different thing. But maybe under the hood it's using the same apparatus. I don't know.
Yeah, I'm trying to remember. There was something I ran into recently with trapping exits that ran into an issue, and it was like, this is one of the things where I say you're not going to find it documented anywhere. Is like when something throws an exception, like what happens to the Y register, right? Does it, does it stay? Does it put some message in there for something else to read out of it, or does it? Because that's normally where the return value would go. So does it like put the stack trace in there, or like there's a whole bunch of things of like what happens after an exception that are just not documented anywhere, and the only way you really know is by just telling it to look at either manually going and parsing through C code, or telling Claude to go look at it and figure out what exactly happens, and then being able to call it like when it says this is what's happening. I think a lot of really being good about being good with AI is it's like you're talking to somebody and you have to be able to know when that person's BSing you, and when to trust them. Like, so you kind of have to have a lot of experience with it and just know what kinds of problems it can solve and can't, and what it kind of sounds like when it's BSing you. Like it gets a slightly different tone, and it sounds much more sure of itself sometimes. And so, yeah, I think a lot of the skills are actually like people skills, essentially, how to deal with it. But, real quick, I just want to look at the example though. So this was that live view WASM example we're looking at. So the way I've structured this is the main library is the root level. This is all Zig code. Zig's a little weird in that, well, I say weird. Zig puts the test generally inside of the code files, but I don't really like that. One, it makes the files so much bigger. Let me find a good example, like GC. This will probably, right? So you see this file is like already 1,600 lines. All of these tests in here are like if I tell the Claude to make a change, like where do the tests actually start? I think the tests start right here, right? So like almost half this file is tests. And so it's actually been better to split the test into two different files, simply because if you tell it to go make a change to the GC, it doesn't have to load in the whole thing. So yeah, there's that part, and then there's this test set, which is all the integration tests and benchmarking tests and stuff. There's like literally tests to test the benchmarks. That's the other thing. Don't let me forget to run the benchmarks. But then examples, right? Examples are kind of like, here's the demos of it doing all of these things. So I put a couple of in here that I started and I didn't get anywhere with, but an idea of like making a CLI. That could be running WASM time. It could be running the actual native, Zig. Like Zig can actually run, I can compile it into a single binary. So there's a couple different ways now to run a CLI. I think conceptually a WASM-based CLI is interesting because you can have pieces of the CLI written in any language. So I might do that. The cell game we looked at is all in here. And all of these also have playwright tests in their own individual example so that I can tell the AI, hey, this thing's breaking. And instead of it having to like go open up the browser and try to look through it, I just tell it to write a test that the example is working. So like the live view one has its own tests. Well, that one should have some tests. Where are those? Does it? No, yeah, they're in here though. They're in the actual web directory. So the live view itself, it's an Elixir app, but then there's a web directory that has the front end, and this has the browser-based test. And then simple OTP, I'll probably get rid of. That was like an example of like a counter and a couple other things that were just running GenServers and stuff. And then the Typhon client is going to probably move out of the examples. It's the JavaScript glue part of it. And this will have to be tested itself. And it's the thing that all of the other ones that are running in the browser should be using this interface with the WASM module. And then a chat server, just to like do like, you know, a little chat example where you have multiple tabs open or something, and then WebRTC connect to people and then network together. So the idea was like each one of them would actually start with a little Erlang VM, and it would actually cluster, and then you would just be chatting by sending a message literally in the cluster to another process, which is the person in the chat. So that's a future project. Yeah. So real quick, let me run some of these benchmarks because I thought this was pretty interesting. I'll kill this one. So I mentioned earlier that Erlang has a thing called eStone. And when I first read the docs, they had an eStone score of like 250,000 or 400,000. It's funny, it sounds like Dragon Ball numbers. It's crazy. And it scales like that apparently. So if everything's run with Mai, so I have like, I can run the examples by doing Mai's example cell game and all that kind of stuff. So I say Mai's bench was the first benchmark I came up with when I didn't fully support all the things that you run in eStone. And so this says run a bunch of functions in Erlang and time everything, and then run them in Typhon and then time them, and then give me like, how bad am I? And right now it says 15x. This number is a little weird because it's an average of these numbers, but you can see that most of them are 32 off, and then these ones being only like so close make the average much lower than it really should be. It's about 30 times slower, really. It's just that these two things just happen to be really fast. But the really interesting part, and the part I didn't expect, and I'm hoping pans out well when I do embedded, is that it only uses 2% of the memory that Erlang uses to do the same jobs. So I need to validate all this for many reasons, because sometimes my understanding of memory and stuff is wrong or something like that. So I need to validate this by actually like putting this in a constrained device and saying to do something that knows, whatever. I can somewhat trust that I think I know what it's doing, but it looks right. And it's consistent that it really does. Like if you run this in a process, you can like look at it. It's using a very small amount of memory. So that, and I think that's all because of Zig. Like Zig's just much like easier to conceptually say like, go, here's a chunk of memory, here's a little chunk of memory, you can manage it. And then when your process ends, I know exactly like where your memory is, and I can just clean that stuff out easily. So at the interesting benchmark, and the one that Erlang actually uses, is called eStone. And I have one called official because at first I had to run a modified version of it because I didn't support ports. But then once I did, I started running this one. I recently just disabled ports, but ports is actually it's weighted to be 12. So like ports are the things that Erlang optimizes performance on more than anything else, probably because because networking runs over ports, and so ports are very critical for their real world performance. But anyway, you can see their score here, and then if I do mine, not Typhon.
It's already slow.
Yeah, right. So I mean, if you look, like when I first looked at it, I was like, oh, I'm pretty close actually. Like they were 300 and something, and I was 300 and something, right? So where's Erlang, right? So, well here, yeah. So here's the problem. I was looking at it like, oh, I'm at 300 something thousand. They're at 300 something. No, they're at 3 million. So I finally got up to where the point where I'm at like 300,000, and I was like super happy about that. But Erlang at some point is now at like 3 million. So I'm still like 10x slower even on this set of things. But it's not as bad as it used to. So when I first started talking to Micah and I had this somewhat working, this benchmark showed me at 135 times slower. And it took a very long time to get down to 60 times slower. And then eventually, like recently, I've started implementing some things and it's gotten down more and more and more. But then you can see like there's things like this, right? Like this Fibonacci benchmark one that has this really, really crazy, like why is that so high? And it'll be something like garbage collecting at the wrong time, has a really small, what they call that. There's a certain amount of heap memory that gets allocated as soon as the process gets created. And if that's too big, then you're just wasting memory. And if it's too small, then it means that almost as soon as you go do something, you're gonna have to allocate more memory. And so you get slower. So you're kind of like playing this thing of like, do I want to really optimize for memory or do I really want to optimize for runtime? And I kind of want to optimize for memory right now because the goal is embedded devices. So I'm not going to worry about that right now, but it's there. These tools are really nice for actually watching this stuff, creep down and slowly get more performance. That's cool. Am I missing anything else? But yeah, another thing also that's really helped is organizing the stuff that this can do in my tasks that are like easy to see. And they're all also recently I had all of them use new shell as their actual script language. Any ones that are doing anything kind of complicated. That way it can run on Windows and Linux without having to have two versions of every task or something. But they're I try to keep this file as small as possible. Meaning like mostly one-line things, but there's some that have gotten a little bigger. But then there's like a scripts directory.
Do you have to new -c everywhere in that file, or is there a way to set the like global environment for mice to new?
There is. You can say this. You can say shell new C. And this is what I really like to do. But the problem is if you do that, it seems like because I have a standard library of scripts here, I still, in order to call this function in it, I have to like have this using statement. So it still looks a little wonky. What I really want to say is say run this shell and also run this other little piece and then run this command, right? Like but in this case it wouldn't help anyway. I'm running multiple commands back to back. But in something like maybe this one where I really just want to write, like this. So I need this to be like run new C and automatically. Oh, actually, you know what? I can't. There is a I think it's an environment variable you can set that'll tell it where your standard library is. And if I set that in the EMV here, then it's possible I can get it to automatically load this in, and I wouldn't have to do this. So, yeah, that is that. Any other questions?
Yeah, I had a question. When you're triaging, you're saying, oh, this is a bug, write me a bug. Do you ever ask it, once it creates that bug, like, can you confirm that it's a bug? And it like comes back and says, yeah, it actually is a bug. Do you want me to solve it? You say, no, don't solve it. Just thank you for telling me it's a bug. And then like, when you're sleeping, because I assume you sleep at some point, like you could have like an automated thing go off that says, evaluate all of the bead issues and determine if all of the bugs are still bugs, or if some of the bugs have been resolved. Like, would that work, or is that like a
that would be if I was working on if I was already set up to where I could work on multiple machines and I could be working on this one and have an agent running somewhere on the same code base and I'm just pushing up, then yeah, that'd be like a good CI process, I think, because that's kind of what Ralph would do, right? Like the process they're talking about of just constantly iterate over it. The big problem is it's so undeterministic that if you have 500 issues, one of them is almost guaranteed it's going to look at it and going to go, yeah, that one's wrong. It's already solved. And it's going to be wrong about it. And so every time it says it, you have to either ask it multiple times or you have to get some kind of human to look at it. So I don't know if I would take automatic action on it yet, but I would definitely, you could probably flag it somehow and say like, yeah, this one's weird. This one's probably done. You should look at it. Or just tag the issue in the beads and have it commit something that says this is possibly done or something. You could have a tag, there's labels and stuff that you add to these things up here. And so you could have it label it something saying possibly a duplicate or, might be done or something, right? That way you can just periodically look at them and see. Yeah, I thought what I thought you were going to ask is, so one of the other things I do with the agents is an agent will implement a fix or something. It'll say like the other day I was having an issue where that the cell game one was running out of memory in some after running for a while, and I was like, hey, fix this issue, and it was like, yeah, I upped the initial memory from 100 or so something like 64K to like 1,360,000, like it was some weird number, and it wasn't even like a power of 2 number. It was just some weird number, and I was like, that's weird. And so what I just tell it is if you say if you say in open code, at least, if you say have the Erlang expert agent look at this evaluate this code or this PR, or not PR, but this commit or the changes or whatever it was. If they'd already made a commit out of it, say, look at that commit and tell me whether or not it was like valid. Will it hurt performance? How does the beam solve this problem? Is it taking the right approach, right? Like, and you really have to tell it, you have to really, really explicitly tell it to be critical of it. And that way it won't be like it's weird because if you ask the AI that's doing the work to evaluate its own work, it will almost always just tell you, yeah, it's right. Like it's totally fine. But if you ask another agent to look at it and you tell it to be critical of it, it will almost guaranteed be critical of it. And then you just have to evaluate if it's being maybe too critical or what. And if it comes back and says, yeah, it's good, it's a lot better of an indicator that it was solved correctly. So that's definitely one thing I would do is just bake that into your routine of either, a slash command or something, is just having a way of having one agent review before you even really get it down and try to review it. Just have the agents review it, especially if it's a complicated fix for something that you just don't understand yet. But also the other thing that was really interesting is like designing the VMs also is a very complicated thing. And it took a lot of time, and I really came right up to the edge of this this meetup trying to get a couple of these examples working. And then over the last 2 days, I was like, oh shit, I got to get those slides ready. And the actual process of getting it to write out live view slides that are even with the fact that they're weird in the sense that they're being compiled into WASM and loaded in that sense is so much faster. So there's weird things that being able to just say at any point in time I could spit out a website. I really just need to nail down this hard problem. That's really, a big relief to not have this thing oh crap, now I've got to spend the next 2 weeks making slides and doing all this other stuff. You could just kind of spit those out. They're not perfect, and okay.
I've been telling it to make me posters. I'll be like, oh yeah, this document's good. Make me a poster of this, and then it does a really good job.
That's actually something similar to what Micah has done. Did I do this one in the probably in the docs here. The GC one should have them somewhere. Yeah, like this. If you tell it to draw diagrams, it's generally pretty good at ASCII art. It never lines these up correctly. But the types of diagrams it can draw are often really helpful. And then when I told it to create the website, am I actually running this still? No. But when I actually told it to create the website, I just told it to make those diagrams, but do it in ASCII, or not ASCII art, but in
HTML.
With HTML, and it can just generate them. And so it's nice to the visual part of it, because slides I think really benefit from having some visual explanation of as useless as this is, we all conceptually know that there's a mailbox or whatever, and this is actually kind of wrong, and right, whatever. There's things that make them wrong, but visuals help people kind of see where the lines are drawn and how many layers are involved.
Even that's wrong. It's all AI generated slop, but we get it.
Yeah, right. Yeah. So this stuff here though, seeing it like this is so much easier to process out or parse out in your head and be oh, okay, I think I get what you're saying here. It's just like going to a whiteboard with somebody and having them draw a picture for you and you kind of disagreeing and say, yeah, it's not really exactly what I want. I don't know if there's any other good ones in here that are nice that I can actually see them in the side panel. Yeah, there we go. Right,
I feel like it's an architecture meeting, right? You're meeting with members of your team and they're going, here's the thing I'm going to present. And you're going, yeah, how does this piece work? Right? And anytime you go to an architecture meeting, even with a human, they bring a document and they show you a diagram, and there's somebody in the meeting that understands that diagram and goes, that piece right there doesn't work the way you think it does.
Yeah.
How do we fix that? And so I think it's the same thing. You're just you're having that, instead of having that conversation with a group of people at your company, you're having it with AI. This picture doesn't work right. Fix it.
Mm-hmm.
Chase, have you ever seen the diagram and been that's wrong, and so you checked in the code base and it was wrong in the code base and it led to you fixing something, or does it just hallucinate these drawings sometimes?
No, it's what it draws here is almost so it can draw a doc and then later you can iterate on your code and the code can get out of sync. But if I tell it hey, go draw a doc or go create a doc, we've done 2 days worth of work in the GC, go make a doc summarizing our GC, it's spot on. Like there's very little that it puts in there that is wrong, like just outright wrong. Like it might misspell a name of something, but it's not just hallucinating the like everything about it. If it hallucinates, it's not, well, if it gets it wrong, often it's because you somewhere have a doc that is outdated or code that's outdated or something that's tripping it up where it sees both copies of it and it's trying to like merge them together essentially. So that's why it's kind of critical to periodically prune this architecture doc with stuff that you don't need anymore, and also like stuff that's out of date needs to be updated, or so that it won't randomly crawl through that one day looking for something and then read it in and go, oh, we should actually be doing this. And you're like, no, you just rewrote everything to be what we had 6 months ago. And it's like, yeah, because you had that doc still sitting in there.
Yeah, like it anchors to it and skews the whole thing for sure.
Yeah.
I found those diagrams really good too. The other thing I like to ask it to do is to when it's to writing the docs for users to do mermaid diagrams as well.
Yeah, I thought about trying to tell this to pull in Mermaid, and I didn't, and I really should have, because it pulled in what's the one that they had the library like anyway, it pulled in the code coloring library, whatever. That's the font. But anyway, it pulled that in like
It's at Prism,
10
right?
seconds. I think it's probably Prism. I think. Let me see what it says in here. Yeah, Prism. It pulled in Prism that fast. And I really could have just told it pull in Mermaid, and it would have been in a generic Mermaid docs, and it would have looked better. And probably and because it's having to think about less markup, it'll get things right better, rather than like when if I try to tell it to like remove this space between here or like these lines, it'll screw up the text in here. It'll inevitably rewrite this stuff and get it wrong.
Mermaid is a like a programming language for graphs. That's the best way I can describe it.
Oh, okay, like a UML.
Yeah.
It's not. See, like you see the top there, like it's got the flowchart LR. It tells it that it's a flowchart, and then
it's got a language.
Yeah, it's a little language for graphs, and so there you go. So like there's a graph.
But you can do UML diagrams, right? Like
or like the sequence diagram here. You can say it's a sequence diagram, and then you give it the participants, and then how they interact, and it'll draw it. So it's like a language, like a small programming language for graphs and charts.
Yeah. And because it's so prevalent. Yeah.
Because
that's what I said.
It's really good at generating it. Sorry, I'll let you talk, Chase. This is your show.
That's what I was going to say. What basically you're saying. It's concise, which means it's easy for the AI to write, and it's so prevalent that it's seen so many examples that if you tell it to draw a mermaid diagram, it doesn't have to think very much about anything other than just this text, not all the layout stuff. And so it's more likely to get things right.
Yeah, the thing that I like too is that GitHub like renders mermaid diagrams out of the box, right? So a lot of Markdown renders are dealing with like mermaid already.
Yeah.
Even my Markdown renderer in Vim renders mermaid.
And there's charts I didn't even know existed that I'm looking at now. Like some of these charts look really useful, and I really have not used them.
I do stuff in there. I don't recognize some of that. That's
the Git graph, that'd be cool. Yeah. But yeah, hopefully I'm gonna try and submit this talk or something like it somewhere, and I'll do a little more work on this and get something hopefully working a little better. Because in the end, what I wanted to be able to do with this is actually have this TypeScript be executable and play around with it. Because nothing like the same thing with the inspector there. You could write Erlang and just have it, I also want that to support Elixir. But anyway, the idea is, if you have one tab that's like Elixir and you have another tab that's your JavaScript, and watch them interacting, I think it'd be a lot. It's a really cool learning tool to be able to just say, go play around with Elixir, now play around with calling from JavaScript. Because when you do that, you're not worried about the language. You're getting down to the essence of why Erlang is good, which is the message passing and like the processes and the isolation and all, right? Because it doesn't matter that you're calling it from JavaScript or Rust or whatever. And so I think seeing Erlang and Elixir operating across the boundary with something like JavaScript, it makes it easier to conceptualize, or I guess fix in your head why it's important. Too many people get hung up, I think, on the syntax of something, because Elixir is super pretty. And I don't really like the syntax of Erlang, but they're functionally the same, language essentially. But one of them is much more pleasant to use, and we get really hung up on the syntax of it. When in reality, the reason why they're powerful is because of the underlying, like structures and stuff they'll let you build. Oh. I was actually one of the things I want to show real quick was the REPL. I didn't build up arrow, which was much harder than I thought it was going to be. So I can't up arrow. There's no past. There's only future. But it does do things like like that. I believe that PID should start at 1. I need to actually look at the. Actually, we can look at it. What is it?
So I would think that if you were in the REPL would be an earlier PID, and that PID would be much higher, like in the hundreds or.
Oh, really?
Maybe.
Well, actually, here we could say. Right, so it's 85, right? So, but if I do something like
Spawn.
how do you spawn? What would you spawn to play around with it? You can't just do spawn, right? You have to spawn something.
Yeah. You could say, well, you have to give spawn an arity, so you can give it a function that's empty.
How do you give a function in Erlang? That's what I'm saying. I don't know, but anyway. So the reason why I say this is I wanted to know, like, yeah, I think this PID is random, and it's higher than what mine is giving, right? All right, I think it's 85 consistently because it loads some number of modules in, or has some number of running processes before I do this or something. I don't know, but yeah, there's things that mine are definitely wrong at. I do, yeah, REPL compare. I haven't run this one in a while, but this was a test that basically just goes through and runs one thing in Erlang and then one thing in Mize or in Typhon, and it tries to say, like, is it working? Is it an expected failure? Like, you already know this exists, or is it currently passing? Like, and like this one's not. This one's skipped. But sometimes it'll be like, hey, you said this one failed and now it's passing, meaning you've actually fixed the problem.
So do you want to try the spawn in Erlang? Because I can tell you how to make an anonymous function.
Yeah.
Right. Yeah, go to Erl. And then do capital, whatever your variable name is, PID would probably be fine.
Oh, I see what you're saying, yeah. Okay.
Equals spawn. And then in Erlang, the functions are fun. FUN.
Oh, FUN.
Yep,
right.
And then an open paren, and then your variable name, but you don't have to give it one, you can just do a closed paren. And then an space arrow. Yep.
Just anything?
And
or
I believe it's end.
End, like that?
Yeah. Yep.
No, it's not. Well, or it might be my arrow. That's the problem.
You might just do like OK there, yeah.
Yeah, there we go. Right. Oh, where did it? Oh, wait, because I tried to reassign PID, and you can't do that, and so I'd have to get PID or something. Yeah. So yeah. But you see, like, they're skipping 2, right? It goes from 93 to 95. Oh, actually, no, it didn't. It was because it created it, but then couldn't assign it, match errored. But is it actually? No, it looks like it is. It's like.
No, it's skipping 2. There's some kind of algorithm that they use for determinism on PIDs. I don't know how it works, but like.
Well, here's the thing, and this is one of the things I ran into, right?
But they have some kind of algorithm that guarantees they won't have a collision.
When you do this in Erlang, I think the way this has to happen is this line has to get compiled to bytecode to run and interpreted different than the BEAM file.
So you used to not be able to do anonymous functions, from my understanding. So the way they actually do anonymous functions, that you could do anonymous functions, but they were very low performance. So the way, my understanding of actually the way that works is when you type fun like this in the console, they do the same thing in real code now. They actually create like a fake module and add that function to that module, and then they call that function from the module so that it gets the same.
Yeah, but I'm not talking about the way fun's working. I'm saying that, like, the REPL itself, like when I do like 1 plus 1, this line has to be like pulled in, turned to bytecode, and then interpreted in some way. And so there's like actually a little piece of the compiler that has to run to turn it into some kind of bytecode or BEAM code, right? Like the opcodes of it, and then run. And so it's possible that the act of putting the line in created a PID and then had to run it. You know what I mean? So I think maybe that could be it. Why it's skipping 1. But anyway, yeah. So mine is a little less good, but it does. One of the things I'm trying to get working is float math, I don't know. Yeah, so that's not right. And then, but if I do something like, right, like, so it's like lowering it, I guess, is what it's doing, like turning it into an
I think it's
integer.
just doing integer math there.
Yeah. But that actually is the VM itself. That's the parsing of this line that's failing. Like the VM itself can do it. There's tests for it, but the REPL itself has to be able to deal with it. So every time I introduce a feature, I have to like work on the REPL to make sure the REPL can do it, because there's weird things that happen there. Theoretically, it shouldn't happen like that. There should be a better way, like where I just deal with it once and that's it. But the REPL is not as high, a really high priority, so I'm not really messing with it too much. But ideally, at least, if I start rendering something in a browser, I really want to be able to like take a module, then run some stuff to execute that module in the browser. So I'll have to get to it at some point. But that's also like, so one thing, I don't compile the REPL into the WASM module because there's some things that it tries to use that are not compatible with WASM. And so there's issues like that I'm running into where I have to not compile in the REPL. There's also pieces that like you don't necessarily need compiled in, and you can like kind of min-max your binary size for the WASM module. If it's critical that you get down under a megabyte, then you don't need all of the features really. And also when I say it's 800 kilobytes, that's just the, oh wait, you can't see it here, but that's just the turn off server, but that's just the my WASM, right? So the rest of it is all going to be like Beam files, and that's I think 10 megabytes of Beam files if you load everything. So there's possibly a way to make that a little more efficient. But that is one of the reasons why I load them one by one, because if they're cached on your client side, then the next time you hit them, you just get a cached version of it, rather than trying to like bake them all into a big WASM file that one line changes and now you have to reload that entire WASM file. Because now 11 megabytes. Anyway, all right. If there's nothing else, that was pretty good.
Yeah, we definitely clap. This is awesome. Fucking awesome, Chase. Good work.
Yep. I'm assuming it works. It might all be written in JavaScript under the hood.